In our previous video, we have seen the projection of points. Now we discuss the projection of line, and there are few different cases. The first case is the line which is parallel to the plane. It may be a vertical plane, it can be a horizontal plane. So first of all, suppose in this first figure, this is the first figure. Here we have a line AB, and we see that that line is parallel to HP. Okay, and that line is inclined with certain angle with the VP. So this is the line here. So when this is the case, when this line is parallel to HP inclined to VP, so the projection, if you see from the top, the projection of this line AB is small alphabet A and B on the horizontal plane, and if we see on the vertical plane, so the projection of this line is A dash and B dash. Similarly, in the second case, we have a line CD which is inclined with HP. Okay, the certain angle, suppose say theta, and the line is parallel to VP. So the projection of this line CD on the vertical plane is C dash and D dash, and on the horizontal plane it is C and D. Now if the line is parallel to both the planes, this is the line EF which is parallel to both the plane VP and HP. So the projection of this line on the horizontal plane is EF, and on the vertical plane it is E dash and F dash. Here we introduce the concept of true length. Here we see that when we are taking the projection of this AB line from the top side in the first case, so this small AB will represent the true length of the line AB. Although this A dash and B dash is not the true length, it is certain reduced length of the line. It is the length of the line is, or projection of this A dash B dash is less than the actual length of the line AB. Similarly, in this case also, C dash and D dash is called the true length of the line, while CD is the reduced length. Similarly, in case of the when the line is parallel to both the plane SP and VP, so EF and E dash F dash will represent the true length of the line. So this is the three-dimensional pictorial representation. If we draw them on the two-dimensional uh, sheet, so we have the XY line. In the XY line, this A dash, B dash, and AB are the projection of this line in the first case when it is parallel to HP. In the second case, the projection is C dash D dash in the VP and CD on the HP when the line is inclined at an angle of theta with the HP and parallel to VP. The third case, E dash and F dash and EF are the projections of the line when it is parallel to both the planes. When the line is perpendicular to the plane of projection, it may be HP or it may be VP. So here we have the line AB, and this line is perpendicular to HP and it is parallel to VP. So when we take the projection of this line, when we see from the top, so A and B both points are coinciding in this case. So we are getting a point on the HP, and on the VP we are getting a line of length A dash and B dash, which is representing the true length of the line. So this is the projection when the line is parallel to VP and perpendicular to HP. In the second case, we have a line CD which is perpendicular to VP and parallel to HP. So the projection is CD on the HP and it is D dash on the VP. It is a point projection of the line CD on the VP basically. So this is a three-dimensional representation. If we see on the 2D, so this is the XY line which represents the intersection of both the planes, and A dash and B dash are the projection the VP, and A dash is the projection of this line AB in the HP. Similarly, here with the D dash is the projection of the line in the VP, and CD is the projection of the line in the on the HP basically. This is the case when the lines are perpendicular to any of the plane. It may be HP or VP. Now the next case is when the line is parallel to VP and inclined at an angle of theta with HP. So suppose we have a line that is PQ1 is the final line which is making an angle theta with the horizontal plane, and this is parallel to VP. So as we discussed, because this line is parallel to VP, so we are getting a true length on the vertical plane. But we start with the first basic case that this line PQ is parallel to both HP and VP. So when this line is parallel to HP and VP, so P and Q is the projection of this line on the horizontal plane, and P dash and Q dash is the projection of this line on the vertical plane. And the length of these projections are equal to the length of the line because they are representing the true length of the line basically, because the line PQ is parallel to the both HP and VP. Now as per the problem, we incline this line PQ by an angle of theta degree with the HP. So we incline this line, so the next position of the line will be P and Q1. And you see that from the back side, this line is making an angle theta with the horizontal plane. Now this is the final position of the line. Now we take the projection of this line. If we take the projection of this line, the projection of this line is on the vertical plane is P dash and Q1 dash. Now how we get it? Now we rotate this point Q dash by an angle of theta degree. Okay, and this now point this the we change the position of this point Q dash from this position to Q1 dash basically. And you see that this line is making an angle theta degree. So with the center as P dash, we make an arc whose radius should be equal to P dash Q dash, and we rotate it up till when we get the angle theta from the HP. So this is the projection of this line on the VP. Now if we take the projection of this PQ1 line on the horizontal plane, so we see that we project this point Q1 into the vertical direction and we got the projection at P and Q1. So this is the final projection of this line PQ1, which is inclined with HP and parallel to VP. Now this is a three-dimensional representation when we draw it on the 2P. So this P1 and Q1 is representing the projection when the line is parallel to VP, and this PQ is also representing the case when the line is in parallel to both HP and VP. So this is the actual projection. So this is the first case. We start with this case. Now as given in the problem, this P dash and Q dash line making an angle theta with the HP. So we rotate this line. So how we rotate? With P dash as center, we arc this point from this Q dash position to Q1 dash position. This is the final position, and this P dash and Q1 dash line is making an angle theta with the HP as we see here. So this P dash and Q1 dash is the projection of the line on the vertical plane. Now from this Q1 dash point, we draw a vertical projector, and wherever this line intersecting the PQ line, we are getting the projection of this line on the horizontal plane. This point we are getting as Q1. So PQ1 is the projection of this line on the horizontal plane when the line is inclined at an angle of theta degree with the horizontal plane and it is parallel to VP. We have considered the projection of the line which is parallel to HP and inclined to VP. So again, as we have discussed, we start with the basic case. First we assume that here the line is R as well as the final line. So we assume that this line RS is parallel to HP and VP both. So when this line is parallel to HP and VP, so we are getting the projection of this line on the vertical plane as R dash and S dash. And on the horizontal plane, we get the projection as R and S of this line. So when we assume this RS line is parallel to both HP and VP. As given in the problem, this line is making an angle theta or say phi in this case here with the vertical plane. So what we do, we rotate this line. We rotate this line with an angle of phi, okay, with respect to point R. So this S point is now arced as S1 point, and now this RS1 is the final position of the line, which is making an angle of phi with the vertical plane. Now how we get it? Now we see that similarly this RS line, which is the projection of this line in the HP, we can also rotate this S point or arc this point from S position to S1 position, which is making an angle phi with this one. So here we see that on the HP we are getting the true length of this line. This RS and this RS1 both are equal to RS1 position. Now with this, now what we get? Now we project this point S1 on the vertical plane, and this is the dashed line which is shown here, and this point now we have marked as S1 dash. So R dash and S1 dash is the final projection of this line on the vertical plane, and RS1 is the final projection of this line RS1 on the HP when the line is making an angle phi with the vertical plane. Now the two-dimensional representation, if we show this, we are representing a XY line here. Now this RS and R dash, S dash is the projection of the line when we assume this line is parallel to both HP and VP. As this line is inclined at an angle of phi with the vertical plane, so what we do, we rotate this RS with respect to point R, and this point S is reaches to the new position as S1, and this angle is phi in this case, and this RS and RS1 representing the true length of the line basically. Now from this S1 point we draw a vertical projector, and wherever this projector intersecting this R dash and S dash line, this point is coming out to be S1 dash. So this R dash and S1 dash is the projection of this line on the vertical plane, and RS1 is the projection of this line on the horizontal plane. This is the final position, and this is shown by the dark lines basically. The next case is when the line is inclined to both the planes HP and VP both. So this is the three-dimensional representation of the projection of the line, and this is the two-dimensional representation in the second figure. So we'll start with the basic one. So we start that here in this case the line is making an angle theta with the HP and making an angle phi with the vertical. This is the case. So as we assume that we start there, first the line is parallel to both the planes HP and VP, and we draw the projection of this line. Now we incline this line, suppose first from the horizontal plane by an angle of theta. So we incline this line AB by an angle of theta with the HP. So this line will come out to the new position as AB in this case, and this is the projection of this line AB, A and B on the horizontal plane. And if we see on the vertical plane, the projection of this line is A dash and B dash, and this line is making an angle of theta with the XY. This is the case when we start with the case here when the line we say that is inclined at an angle of theta with the HP. Now as we see that, so in the previous slide we have seen that how to get the projection here when the line is inclined to HP and parallel to VP. This is the case first of all. Then we rotate this line AB by an angle suppose phi, because phi is the angle with this line AB make with the vertical plane. So with this A as center, we rotate this line to a new position from B to B1 by an angle of phi, because this line now A B1 is making an angle phi with the vertical plane. If we see the projection on the horizontal plane, so this B point will now rotate from B position to B to B1 position. Okay, and the angle between B to B1 is again phi basically, and the horizontal inclination of the line AB and AB1 is theta, same. Now we can project this point B1 point, we can project on this vertical plane, and this projection is coming out to be B1 dash. Okay, so this PQ is the locus line where this point B1 is moving from new position to B1 dash. And as you see in this case, as this point B is moving from this position to B1 case, so if we see the projection of this point is reaches to that position. It is at the same height from the XY line basically. OB1 and you can say OB1 dash in this case is same basically, and this is the, so A1 and B1 dash is the projection, final projection of the line which is making an angle theta with the HP and making an angle phi with the VP. Now this line is having inclination of alpha with the HP in the new position, and this A and B1 is the final projection of the line on the HP. Now if we see the projection on the 2D, so we see that AB is the projection of the line on the HP when it is inclined at an angle of theta with the HP, and this A1, A dash and B dash is the projection of this line, okay, on the vertical plane. Now as we see that this line is making an angle phi with the vertical plane, so with A as center we arc this point from B to B1 position, and this angle is phi here. So this new position is reached to A B1. This is the final projection of the line on the HP, which is making an angle theta with the vertical plane and making an angle phi with the, this angle is phi with the vertical plane. Now we project this point B1. Okay, so this we can draw the vertical projectors from this B1 point, and these vertical projectors are cutting this PQ line locus line as B1 dash. Now we join A dash with B1 dash, which is making an angle alpha, and this is the new position of the projection of the line on the vertical plane when it is inclined with HP and VP both. But B1, B dash and B1 dash, they are at the same height, because this B, the angle with this B and B dash, or this line AB and AB dash are making same angle theta with the horizontal plane. So these 2 points are at the same height from the XY line. So this is the final position of the inclination of the line when it is making an angle theta with the HP and making an angle phi with the VP. Now we discussed in the previous slide that first the line is making an angle theta with the HP, and then we incline the line with an angle of phi from the VP. Okay. Now the same projection we can also get, Okay, by starting first means the line is making an angle phi with the vertical plane, and then it is making an angle theta with the horizontal plane. So this is the case. So first of all, we got the line AB here, which is making an angle phi with the vertical plane, and the projection of this line on the horizontal plane is AB2, and this AB and AB2 are of true length. They are representing the true length of the line basically. But if we see on the vertical plane, the projection is A dash and B2 dash, and this length of this projection is shorter the actual length of the line AB. So this is the final projection of the line when it is making an angle phi with the vertical plane. Now, as given in the problem, now this line is making an angle theta with the horizontal plane. So what we do, this line AB we can rotate from, okay, about this point A, and this B point now rotate by an angle of theta degree and reaches to the new position as B3. Okay, and now this AB and AB3 line, they are inclined at an angle of phi from the vertical plane, same inclination. So in the same plane, this line is rotating by an angle phi and reaches to the new position as B3. Now we draw the vertical projectors, or we see the projection of this line B3 on the horizontal plane. So we see that the projection of this line B3 on the horizontal plane is B3 here, small b3 here. Now we join this A and B3, we got this final projection of this line, which is making an angle theta with the HP and making an angle phi with the vertical plane. This B3 point can also we get in the two-dimensional representation. Means we got this projection of this point B3 on the vertical plane as B3 dash, and now we draw the vertical projectors from this line B3 dash, which is meeting this XY line at this point, and then draw the horizontal projectors, and we are reaching to the point B3 here. And this RS is the locus of the line where this horizontal projection projected point B2 is moving from the new position to B3 point basically, and they are at the same angle from the vertical plane at an angle of phi basically. Now if we see on the two-dimensional representation, so we start with this A, then A dash and B2 dash are the projection of the line on the vertical plane, and A B2 is the projection on the horizontal plane when the line is making an angle phi with the vertical plane. Now what we do, we rotate this line A B2 dash by an angle of theta degree about this A dash point, and this angle is theta here, and this point B2 dash is now reaching to the B3 dash here, and this angle is theta basically because this line is making an angle theta with the horizontal plane. Now we project this B3 dash point on the horizontal plane. Now we draw the projectors here, and we see that these projectors are meeting to the locus line RS at this point B3. Okay. Now this point B2 is changing from this position to B3 position, and this is the, if we see the inclination of this B3 line, it is making an inclination of beta from the XY line basically. So this A dash and B3 dash and A and B3 is the final projection of the line when it is making an angle theta with the HP and making an angle phi with the vertical plane. So in the previous slide, we start first with the line which is making an angle theta with the HP and then inclined by an angle of phi. In this slide, we first consider that the line is inclined at an angle of phi with the vertical plane, and then it is making an angle theta with the horizontal plane. Next, we consider the projection of the line when it lies in the profile plane. So this is the profile plane, this is the horizontal plane, and this is the vertical plane, and this is the profile plane. Profile plane is a plane which is inclined at an angle of 90 degree with both HP and VP. This is that plane. If the line EF is lie in that plane, basically in the profile plane, then we see the projection. The projection of this line on the vertical plane is E dash and F dash, and on the horizontal plane it is EF. And this line is making an angle theta with the horizontal plane, and which is making an angle phi with the vertical plane here. So we know that the sum of the angle is 180 degrees. So this way we can find out, and this angle is 90 degree here. So this is the final projection of this line which lie in the profile plane on the horizontal and the vertical plane. This is the two-dimensional representation. So E dash and F dash is the projection of this line on the vertical plane, and E and F are the projection of this line on the horizontal plane, and they are in the same plane basically. I mean, they are in the same along the same line basically. So this is the projection of the line when it is in the profile plane. Next concept is the trace of a line. The trace of a line is normally defined as when the line is intersecting with any of the plane. So the point of intersection we are calling as the trace. So here if we see, when the line is, in the first case we assume the line is parallel to both HP and VP, and the projection is AB on the HP and A dash and B dash on the vertical plane. Because this AB line is not intersecting anywhere on any of the planes, so we are not getting any trace in this case. In this diagram it is also shown that this is the projection on the two-dimensional sheet, this is the A dash and B dash is the projection on the vertical plane and AB on the horizontal plane, and we see that no trace we are getting in this case because this line is not intersecting any of the plane because it is parallel to both the HP and VP. Now if suppose in the second case the line is CD which is making an angle theta with the horizontal plane and which is parallel to vertical plane. So when this is the case, so the projection of this line is C dash and D dash on the vertical plane and CD on the horizontal plane. Okay. Now we see that this CD line is intersecting the horizontal plane at this point which is called as HT. So this is normally we call as a horizontal trace. We know that this line is intersecting the plane at HT. So that point is called as trace, and that is the horizontal trace because we are getting that trace on the horizontal plane. So now how we got it? Now we to get it on the two-dimensional sheet, let us see this. In this case, this C dash and D dash are the projection on the vertical plane, and CD is on the horizontal plane. So what we do, we extend this line CD dash, and we see that this line is intersecting at the XY line at point H. So from the H line, we draw the projectors, and wherever this intersecting this CD line, we are getting the horizontal trace because this in the three-dimensional easily we can visualize it, but to draw on the two-dimensional sheet, this procedure normally we have to follow. So we extend this C dash D dash line intersecting at point H. From this H point, we draw the vertical projectors, and wherever they are meeting this CD projection line, so we are getting the horizontal trace. In the third case, we have the line which is parallel to HP and inclined to VP by a certain angle. So this line is supposed to say EF. The projection of this line on the vertical plane is E dash and F dash, and on the horizontal plane it is EF. Now if we extend this line EF, so we see that it is meeting with the vertical plane. Clear? Because it is parallel to horizontal plane. So here we are getting the vertical trace. Clear? So this is the vertical plane because this line is intersecting at the vertical plane. Now how to got it? Now what we do, we you can say extend this EF line, the horizontal projection of this line, and it is meeting at point V. From this V point with the projectors, and where these projectors are meeting with this extension line of E dash and F dash, there we are getting the vertical trace. So this is shown in this figure. Here E dash and F dash are the vertical projection of this line, and EF is the horizontal projection. Now we see that as we extend this line EF, it is meeting at a point V on the XY line, and from here we can draw the projectors, and wherever these projectors are meeting the extension line of E dash F dash projection, so there we are getting the vertical trace. So this way, in many of the problems we have to get the vertical trace, and we have to draw the vertical traces also. In the second case, when the line is perpendicular to any of the plane. So the first case is when this line PQ is perpendicular to HP and parallel to VP. So we are getting the P dash and Q dash as the projection of this line on the vertical plane, and this P and Q point are coinciding. So we are getting a single point here on the horizontal one. So because we see that PQ is parallel to vertical plane, so and it is intersecting. If we extend this line, it is intersecting at this point. So we are getting a point on the horizontal plane as a trace of this line. So P is the horizontal trace of this line. Similarly, if we have a line RS which is perpendicular to vertical plane and parallel to horizontal plane, so we got the projection RS on the HP, and this point S we are getting the projection if we see from the here. So R and S points are coinciding. So but S point is the first one, so it is visible as S here. So H dash is the projection of this line on the vertical plane, and because this line is intersecting at this point S dash, okay, which is same as the vertical projection of the point, so this S dash is the vertical trace of this line. On the two-dimensional representation, if we want to show, so this P dash and Q dash is the projection of this PQ line on the vertical plane, and on the horizontal plane this P dash is the projection of this line, okay, which is a point basically, and this is also the horizontal trace. In the above case, because PQ line is parallel to the VP, so we are getting no vertical trace. Similarly, when the line RS is perpendicular to VP, so we are getting the projection RS on the HP and S dash on the vertical plane. So this S dash is the point which is intersecting of this line RS with the vertical plane. So here this S dash and VT are same, means the vertical projection and vertical trace are coinciding here, and this RS is, because it is parallel to HP, so we are not getting any horizontal trace of this line. So this is the concept of horizontal trace. So thanks for watching this video. If you like this video, in this video we discuss about the projection of lines when the line is parallel to both HP and VP, when it is parallel to one of the plane inclined with the other planes, and when it is inclined with both the planes. We discuss the projection of line in the profile planes. We also discuss the concept of traces. So if you understand this video, see this video completely till end of this video, and if you understand the concept of the projection of lines, then please like, subscribe and share this video. Thank you very much.